and then we'll get started in just a minute.
I don't think VC is really worried about saving money. Well, it's part of the green initiative.
Are you doing kind of like at the very beginning? Are you doing kind of like this is an intro, kind of shifting gears, or do you want me to make a comment or whatever? Are you gonna do something like that? Kind of
You can. My intention was to shift. I haven't been like watching what people are working on. So.
Yeah. I mean, we've been doing database stuff, and then yesterday we did like Node and Mongo a little bit and some stuff, but mainly database stuff. So
if you have stuff you want to say, or Vali does, feel free.
I don't. It's just.
But I was going to start with put everything on the shelf.
Yeah.
Just start with.
Yes, that kind of.
Yeah. Although there's a lot of visually JavaScript and C# can look the same.
Yeah.
They're not, so let's just put it on the shelf.
Yeah.
Oh, nice. So great. I mean, I could wear my llama onesie in here, but I don't know. And I have the llama slippers to match it. And a shirt that says no problem. That's cute. Yeah, I like that one.
Well, at least it learned. So that's, oh, she said sign. How do we decide? Maybe, yes, not now.
Hey.
All right, we got it.
All right. Is everyone here? Should we actually get started?
Yeah, let's go ahead and get started.
Go ahead and get started.
Yep.
Okay. Hello again. I'm Derek, if you don't remember. Hi. Hi, Winston-Salem. So the very first thing I just want to touch on, we are going to be using Visual Studio 2017. All of you need that installed. If for some reason it's not, just raise your hand and hopefully Harper or someone in Winston-Salem will help you. You'll know if you have it because if you try to search for Visual, you'll get Visual Studio 2017 desktop app. I have it as an icon at the bottom there. It looks purple. And if you run it, it looks roughly like what's on my screen right now. Use this opportunity to get that installed and make sure that that runs. Just want to start with that. But first, I'm just going to start by talking a few minutes. You all have been working on databases for a long time, right? We've spent many days talking about that. I, of course, talked about Transact SQL and SQL Server last week. You've been looking at Postgres and other tools. I watched a little bit of the stream yesterday, so I saw what you were working on yesterday. There was some JavaScript early on, HTML and CSS. Those are all wonderful. But today I'm going to ask you to sort of put all that on the shelf. Don't forget any of it. Obviously, it's all important. But we're going to start talking about a brand new language, and it's not really like the others. There's a little bit of overlap that I'll touch on from time to time with JavaScript, but I kind of want you to clean the slate. So all the stuff you're learning about HTML and what's a TR tag and what are these tags and CSS markup and how to center things. None of that applies. There is no overlap. And in fact, there are a number of words I'm going to use, a bunch of nouns I'll introduce to you, that are the exact same word but mean something different. So you've heard about classes in HTML, and of course you probably use Bootstrap to manipulate those. We have classes in C# too. They are in no way related. So it's probably best for you to kind of put all that on the shelf, and I'm going to start fresh today. We're learning a brand new language. Just think of this as a brand new day one. So first, I just want to spend just a moment just chatting just a little bit and sort of tell you what language we're talking about and where it is and sort of the global ecosystem. So just real quick, the .NET framework, which I'll talk about what that means, came out approximately year 2000. So it's about 18 years old. Before that, Microsoft's big language that was really friendly, high level to use was Visual Basic. In fact, I started my career in Visual Basic. And in the late 90s, they basically, there's a team at Microsoft. They brought in a guy whose name is Anders. I think he's still in the project, to lead it. And they said, we want to have a new development platform. We want new libraries. We want a new technology. We want multiple new languages, because all they really had was Visual Basic. The rest of the world had things like C and C++ and Java. And they said, we want to start fresh. You know, this is Microsoft's thing. They really wanted to be a big powerhouse here. They wanted a real language, real frameworks, all the stuff they wanted. So they did that. So what they came up with was this idea. It's a .NET framework, and it was only for Windows. And it was only for Windows for about 15 years. So for about a decade and a half, which is a long time in this industry, it was Microsoft only. They came up with the .NET framework, and I'm going to be using that term a lot today and tomorrow and in the coming week. What I want you to just think of is, obviously you have CPUs and systems, right? You have operating systems that are written on top of that. I want you to think of .NET framework as on top of the operating system, but still beneath what we're going to be working on. So it's like this middle layer. It's a common middle layer for multiple languages, and one of those languages is C#. The other one is Visual Basic.NET, which is the successor to the old school Visual Basic. You might have also heard of other languages like F#, and there's some other smaller ones that are written to sit on top of the framework. So just think of it as operating system, framework, and then multiple languages. Just think of it sort of visualized like a stack. But we're going to be talking about C# most of the time. But I wanted to sort of start off with that because we're going to be talking about some things even today where it might not be clear where in the ecosystem that we are. I think C# last time I checked has something like 6% market share of the total market share on the planet. That's about equal to JavaScript. It is dominated by languages like Python, so it's a little bit smaller than that. But it's a totally different kind of language, which I will talk about. And all I want you to do is watch right now. You're not going to follow along. But you guys have been using probably Google developer tools, I assume. Yeah, they're really powerful, so I expected you would. I just want to show you something on my screen. Oops. And I'm not a strong JavaScript guy, so ignore any typos I make, please. So I've got the console window open, and I'm going to type a little bit of JavaScript just to show you something that's possible in JavaScript, and I'm going to explain why it's possible, and then I'm going to tell you about C# a little bit. So I'm going to create a new variable, var, and you don't need to, you can follow if you want. It's not critical that you do though. I'm going to give it the number 1. So if we check on that, alpha is the value of 1. I can increment that. I can do alpha plus 1. It's one of the many ways I can increment, but I'll choose that way. And it obviously increments it to 2. That's probably not a big surprise to you. Let's do a brand new variable, var bravo. I'm going to call that one zebra. That's a string. You can see I put double quotes around it, so we can obviously read that out. We can use it anywhere we want. We can do concatenation. Bravo, oops, make sure I type it correctly. Plus hello. How about that? Zebra hello. You've probably tinkered with JavaScript enough at this point that this is not a surprise. Let's see if we can surprise each other. Charlie plus alpha plus bravo. What do you think this will do? Let's see. 2 zebra hello. So what it did, it used the plus operator. It took the string of zebra. It knows that it can't actually add 2 plus zebra. There's no such thing. It's not a math problem. So it said, well, I'll convert that 2 to a string version of 2, and concatenate them together. That's a little bit weird to me as a C# guy, but it gets even weirder. Charlie equals 3. Now Charlie's just 3. But I could also just reset Charlie to, I'll do giraffe this time. And that works. Now in JavaScript this is perfectly fine. If you're typing code that does this sort of thing, it's fine. But I want to point out something that's happening that you might not appreciate yet. JavaScript is what we call a dynamically typed language. Dynamically typed. Dynamic meaning change, and type. We'll talk more about types later. I'll get more explicit about what a type means. In this case, we had alpha was a type that was integer, which is number 2, and zebra was originally a string. And you've seen me manipulate those 3 variables a few times on the screen here. So what does dynamically typed mean? It means that the language allows you to change the type of a variable. It's very flexible. It's very powerful. I was able for Charlie, which was originally an integer, to change him to a string. Its type was string. No big deal. And I could change it right on back. I could do Charlie equals 4. That's perfectly fine as well. It's very flexible. Its type can change. It can be one type 1 second, one type another. I want to compare and contrast this because of all the really popular languages in the world right now, they all fall into one of 2 categories. They're either dynamically typed, which is what JavaScript is, or they are statically typed. And that's what we're going to be talking about today is C#. I will show you some similar code very shortly in C#, and what you're going to see is that the language explodes in my face. I cannot change types. And I just wanted to start with that today. I know we're not touching the keyboard yet, but this is going to be a big difference from what you might be used to. There are a lot of things that are possible in dynamically typed languages that become impossible in statically typed languages. You can still get the same business need met. I don't want you to think that the languages are weaker. It's just one of them is stricter about types. If I were to type something that's an integer and try to set it to giraffe in C#, which I will do in a moment for you, you'll see that I just get red squigglies. It won't run, it won't build, I'll get errors, it will explode. It's very strict. So C# is a language where the types are considered a critical foundation of the language. If something is initialized as an integer, like your age, it will always be an integer. It can never become something else. If it starts off as a date timestamp, it can never be turned into a string. That type can't. There are conversions, then we will talk about conversions. So I just want to start off with that fundamental difference. I think it's a good thing to start off with verbally, but you'll appreciate it soon because we're going to start typing C# really soon. We're going to get to it really soon this morning. And if you're used to the flexibility and the comfort of I can just use variables any way I want in JavaScript, C# is going to slap you in the face. It's going to stop you. It's going to be very strict. That seems like a disadvantage, but as I teach this part of the course, hopefully you'll appreciate what the advantages are, because there are advantages. So let's waste no more time. So that's sort of the history lesson. That's where we are in the ecosystem. C# is pretty popular. Originally a Microsoft product. It just recently, a couple years ago, officially went cross-platform with something called .NET Core. Everything we're going to talk about in the core, everything we're going to talk about in the course that I'm going to show is .NET Core. I will try to sort of verbally tell you when it deviates from the original .NET framework. The majority of .NET projects are the classical framework right now. So if you get a job right after this course, you're very likely going to be on classic .NET framework. But I still decided to show Core because it is 2 years old. It's mature enough now to talk about, and its adoption rate is huge. It's very fast, and its adoption rate's because it's cross-platform. People can basically run C# on much cheaper platforms. We looked at a Raspberry Pi. I know Harper stood up and we passed around a Raspberry Pi last week. I, in my own apartment, have written C# and that runs on my Raspberry Pi. That was not possible as recently as a couple of years ago. I would have been laughed off the planet if I'd suggested to fellow developers that I could run C# on anything but a Microsoft operating system. That's changed. So the world loves that, and the adoption rate's high. So to prepare you for a long career, hopefully, I decided to do only Core. I'll point out the subtle differences in the two from time to time, but mostly the language is the same. The libraries are mostly the same, but I will mention when there's a couple deviations. But let's get started. So I want you to run Visual Studio. Just open it up. I have an icon down here. It's a little purple icon, but you probably won't have that yet. If you just do the Windows S for search, type Visual, as long as you have it installed, it's probably going to be the first one there, Visual Studio 2017. Go ahead and get that open. When you open it, it'll look something like this. I use this laptop for a lot of business. If it shows you any sort of pop-ups, just try to get past them. I've forgotten what they say, but just get past them. You should see something roughly like this. It might not have this white part here on the right, but this will be Visual Studio. So I do want to talk a moment about Visual Studio and what it is. So Obviously, I've already asked the question. You guys have used the developer tools in Chrome. This is sort of a browser. I don't even know what to call this. I don't want to call this an IDE, but it gives you lots of powerful tools here in the development area here. You can write code in Notepad. I suggest you probably not do that, except maybe to tinker and learn how things work a little bit. In the real world, we generally use, and by we I mean professionals working on large-scale projects. We can't really use things like Notepad. We got to use real editors. So there's a lot of synonyms here. You'll hear people call them an editor, or a text editor, or a code editor. You also hear IDE, which stands for Integrated Development Environment. You also hear development environment, and on rare occasions somebody will just call it an environment, although that word is overused, so hopefully you don't hear that. All those are synonyms, and Visual Studio is an integrated development environment. Visual Studio has been around for a long time. I used its predecessor back in the 90s for Visual Basic. Visual Studio came out sometime in the 2000s, I think pretty much in lockstep with .NET Framework. I want you to think of it as an extremely powerful, large, but bulky tool. It's obviously from Microsoft. This is their flagship product. The community version is free, which is awesome. It used to be called Express, so if anybody tells you to open up Visual Studio Express, they mean community now. It's just the old free version. It's a very powerful IDE, and sometimes, in the world there's a lot of critics of Microsoft. It's very fun to hate on Microsoft. I'll hear a lot of fellow developers who maybe are really hardcore Apple people. They like to criticize pretty hardcore. But I think even a lot of those people will admit that Visual Studio is a powerful editor. It's one of the few things that kind of shines where other critiques of Microsoft actually have a lot of weight. Visual Studio is powerful. I do sincerely like it. As we play with it, I think you're going to feel why. Its IntelliSense, which is its automatic drop-downs, its tooltips, and some of its development tools that are built into the system, I think you might fall in love with pretty fast. If you're used to developing, even in something like VS Code, which I use, I like VS Code. When it comes to some of those more advanced tools, VS Code doesn't come with them natively, and some of the extensions are still not as great as Visual Studio. There is one downside to Visual Studio. I guess there's a few. It is bulky, so a lot of people accuse it of being a memory hog. It is, but it's because it's got so many features. So once you have it open, let's create our first application. Let's go to File, Start, and I do want you to follow along now. It's time to play now. New, pardon me, File, New Project. And I'll try to stabilize my mouse here. New project. You'll get this pop-up, or one like it. So on the left side, they give you lots of abilities. So on my machine here, I can create all kinds of projects. I can do Visual F#, Azure Data Lake, which Azure is the cloud provider for Microsoft. I want you to make sure you've expanded under installed C#. And you have a lot of options here, which is kind of cool. You kind of get sort of a hint at some of the things you can create on the fly here. But we're going to always pick, for the remainder of this course, .NET Core. So make sure you click on .NET Core. When you click on that, it's changing this list here to what you can pick. We're going to pick the first one, Console App. Pick wherever you want to put it as far as location. And I'm going to end up naming mine Alpha. I'm going to flip the screen just a moment. I'm going to put mine all in a location of my choosing on my laptop. You can put it anywhere though. Where you put it is not critical, but you may want to remember where that is, because we're going to be going to the file system at that location a few times. So I'm just going to call mine Alpha. We're just going to be playing, so I don't need to give it a really powerful name or meaningful name. And you click OK. It'll think for a moment, and this is what we'll get. Anybody here in Richmond not see this or need help getting to this look? All right. If anybody in Winston does not see this, we'll need somebody out there to help them. So before you touch anything, let's just talk about a lot of stuff that's on the screen. You should have a Solution Explorer on the right. It might also be on the left. In fact, I'm going to go to OBS real quick and scoop myself down out of the way. There we go. Hopefully nobody got dizzy there. Solution Explorer should be there. If you don't see it, there is a View menu, and it's the first option. You get that Solution Explorer open. If you accidentally have it closed, I'll close it just, whoops, that's more than closing it, that's completely disconnecting it from the world. If it's missing, if you just have the code like this, you just go to View, Solution Explorer, and it should pop up somewhere on the screen. So let's talk about everything that's on the screen real quick. It opens the very first code window for you, but on the right's what I really want to focus on, so I'll put the mouse here. It's opened a solution. So what a solution is in the Visual Studio world, a solution is a very tiny file, it's got a lot of metadata, and it's just what projects are in the file, are in the solution. I want you to think of it like this. You could write a product that needed 3 different applications. Maybe it needs a console application for the developers to use, it needs a web application which the end users will see, and maybe it needs a telnet application, something that remotely can be accessed from some other developer somewhere in the world. Well, you might want to put all those 3 projects, since they're all those 3 applications, they're all sort of part of the same product that's being purchased, in a single solution file. So solution files are just a way to organize things, and we always open one at a time. So that's what solution means. We won't be talking about that much more. Just think of it as a big vat of projects. And each project can be an application or just a library, and I'll talk about libraries in a moment. It went ahead and created one project for us, Alpha. That is a console application. You can confirm this in many ways. If you want to right-click on that and go to Properties. We're not going to change anything here, but you can see it says output type console application. You've got a few options there, but I'm going to leave it console just so you know. So in case you're wondering what's console application, a console application is something that can be run from a command line. I assume we've done some stuff on command line or git bash or something. Great. So it's something that could be run here. If that were a program that I'd written, it could be run here. So we're going to be talking about consoles for most of this course. We will get into the web stuff after July 4th, after that week. Okay, so we've created a technically it's already created for us. So I'm going to close that properties window and get back to the single code window. So I will go ahead for fun, actually not yet. I'm just going to talk about what we already see on the screen. So one of the things that's common in C# or any .NET project you work on, we generally have lots of files. That's not necessarily true for some other applications. I've worked on a lot of projects where the JavaScript for the company was basically one file, or maybe one file per web page, so the quantity was pretty low. That's going to be different in our C# experience. We're going to have lots of files. I've worked on projects that have many, many thousands of them. They're usually a high quantity of small files, at least on projects that I would consider well architected by some sort of tech lead. They're usually pretty small. What you see on the screen right now, this one file, is actually a complete application. And I'm going to talk about what we're looking at. So let's look at line 1, using system. And let's look at line 3. These two are very similar, although they look different on your screen. So the .NET Framework has this concept of namespaces. They're very simple. They are for organization only. They're just for organization for our benefit. Namespaces organize things. Okay? They actually support a dot syntax. You can think of each word between the dots as a folder. In this particular case, we've created a project called Alpha, and it has a single namespace called Alpha, which contains only one class. I'll talk about class in a moment. This using statement is similar. This is where you in this file state which other namespaces in the universe you want to have present inside this file, which ones you want to use. So what this means is the people at Microsoft about 2 decades ago created a set of code that we do want to use, and they put it in a file that had namespace space system. And they put all the code in there. They put it in lots of files. They put them all in that namespace, and now we're saying at the top we're using what's called the using directive to say we're going to be using some stuff in the system namespace. So line 1 is we're going to use some stuff that Microsoft wrote, and line 3 is our project. Our project's named Alpha, so we said we're going to call everything in our project Alpha. They are totally customizable. You do not need to follow along. I could name this anything. I could do .anything, .to. I could put whatever I want, and it works. It's just a way to name something. Think of it as a prefix. but I'm going to remove that. That was just an example. And then we see line, you're going to see lots of curly braces. The curly braces are the same as pretty much the same as you would see in something like JavaScript, right? They're just sort of a way to mark up blocks of code and separate things. So the curly braces you can trust as being very familiar if you've already worked in a language like JavaScript or C or C# or Java. They all use curly braces in the same way. So this open curly brace says everything in here is in the namespace alpha. No big deal. Then we have a class. I'm going to be talking about classes a lot in this course. For now, I just want you to think of it as a set of code. So a namespace can contain lots of things. One of the types of things it can contain is code, and we put the code in classes. Classes are not the only place we can put it, but to just get us started right now, I'm just going to say classes are where all the code is. And then we have what we call an entry point. This is just for console applications. Console applications always have a static void main that takes in an array of strings, which are command line arguments. And then we put all of our code right there. So when you do file new project in Visual Studio, it actually gives you a fully written program that can run immediately. And it'll just, all it will do is write to the console, hello world. So let's run it. There's two ways to run it. At the top middle is a little green play button, has your project name in it. You can click that. Or, and you're going to see me do this for the whole week, I'm going to press F5. So whenever I say I'm running it, I'm pressing F5. So that's the magic. So go ahead and run it either way that you want right now and watch your screen really closely. You'll notice some stuff flickering at the bottom. Your mouse icon might change. You may or may not see this black box pop up, depending on the speed of your computer. You'll see it disappear. You may or may not see that progress bar, and then we're back where we started. So I'm going to do this again. I'm going to run it a second time. It'll be faster this time. Boop. It's gone. So what just happened? Many things happened. It built the program, and I'll talk about what this in a moment. It ran the program completely, but the program immediately ended and it closed. And the cool thing about Visual Studio, it actually did something extra. It actually latched onto the application, actually ran it, and attached to it. We call attaching for debug purposes. It attached to it and then closed. And in fact, the more you run it, usually gets pretty fast. If your laptop's really fast, that black box is up so shortly you might not even see it. It might just sort of blink for one frame and your eyes don't even pick it up. So you actually have run your first program. Congrats. Not very exciting just yet. But we're going to do a cheat, and I'm going to be using this cheat for a lot through this course. Let's add a new line. Okay, so right after console write line, it does end in semicolons. C# is one of those languages you got to end it with semicolons, just like JavaScript. Let's do console, and you'll notice already something cool has happened. As you begin to type console, this box popped up with some help. We call this IntelliSense. You may have seen this in other editors so far in the course, probably. The one here in Visual Studio is extremely powerful, and it's live. It's one of its best features. I know it seems kind of subtle, but just appreciate you're working on a project with thousands of files, a team of 20 people, over 1 million lines of code, and you're trying to figure out the name of a method a person wrote 3 years ago who was fired. It's kind of hard to track down what you need. This IntelliSense is extremely powerful. So if you type console, you'll see it already is trying to figure out what you're typing, and it gives you a list of everything that's kind of in scope right now. And this is based off that using directive at the top, as well as what I would call local scope, which is things in the current class. But hit dot at the end of it. We use dots to separate all kinds of stuff in .NET, so be ready to hit dot lots. It's a separator. So what we basically said is, for the console, please, and we haven't finished the statement, but we're going to ask it to do something. Once again, you'll get a nice long list. This is everything you can do with the console. We're not going to read through this whole list right now. We're going to pick one that happened that already exists. It's read key. And if you start typing read, it'll start limiting that list right down. And you can even select read key, and I'm going to hit tab. It will auto-complete. Read key is a method. You'll notice if I open that paren, this is the other thing I said was powerful about Visual Studio. It gives you really great pop-ups. So it tells you all about read key, and it gives you a nice description about what it can do. We're using it as a cheat right now. So the purpose of this method is to read a key of user input to do something with it. But we're actually not going to do anything with it. We're just using it to pause the screen. So put a semicolon at the end of that. You'll notice, by the way, leave your semicolon in, but I'm going to take mine off for a moment. This is kind of like Microsoft Word. You get red squigglies immediately. Another good thing about Visual Studio is it's constantly pretending like it's building your code. It's trying to compile it at all times. And so it very quickly gives you feedback if you've broken something. So if you'll notice, it's very small, but where I'm wiggling the mouse, there's a little bit of red squiggly. And in fact, in this scroll bar over here, there's now a red dot. You can see the red dot here. So it's very quick to pick up on our errors. I'm pointing this out to you because we're going to start exercises this morning, and inevitably you won't type it correctly the first time, right? We're all learning. Red squigglies are the best place to start if it's complaining and won't build. So be on the lookout for those. Visual Studio gives very accurate, fast, red squiggly feedback, and I love that. All right, so we've done read key. You can save the file if you want, or it'll auto-save. Let's run the application again. I'm going to press F5. You can also press your alpha green button at the top, and it will run the application. But we're cheating here a little bit. We've asked it to take one character from user input. That's what the read key does. It pauses the app. So we've cheated, and we've turned it into a pause. And now you can see it says hello world, which, if I move this out of the way, is the text there. Right? So to end your program, you can do it a couple ways. If you press one key, that read key will occur. The end of the main method will occur, and it will close down the program. There is also a stop button in Visual Studio itself. You can force your application to be forcibly stopped in the middle of your work. Either way works. I'm going to click stop this time, but I could have just as easily pressed a key. So for fun, let's change the code. Let's make it personal. It says hello world. Make it say anything else. I do not care what you type. I'm going to say hello empower. And I'm going to press F5 and run it again. Just to show you that I'm not lying. This is a real application and it really runs. And it took my change in there. So that'll be your first custom application you build in C#. Congratulations, you're now a C# developer. There's a little bit more to learn. That's just the very simple beginning. And I closed that out. So once you play with that and you can see that that works, that's cool. Now before we start really experimenting with the language, I want to talk about some of the things that are happening really fast under the hood here that are going to be important for you to know. Let's see here. I think I'll go to the file system. So if you want to open your file system and go to where your program was, this is why I told you make sure you knew where you placed it. Mine's in a location called alpha. I'm going to use a little hotkey action here to put the application next to the file system. And if you go into that folder where we created our solution, let's look at the file system just a little bit. I want to remove all the magic, because right now it's kind of, we did file new project and who knows where all this is stored and what are these files doing and what is what. So let's kill all the magic here. Let's look at alpha. You can see in the root, it might have created one folder. That was the name of your project. You might have to navigate into that. But if you navigate in, you should see an SLN file. That's the solution file. We're not going to open it. It contains a bunch of global unique identifiers and gobbledygook. Remember, it's just an organization mechanism. All it's doing is pointing to projects. Well, we do have one project which happens to have the same name. So we can go into this other directory called alpha. And as you'll see that there's a CS proj. CS project file is very important. We're not going to look at it right now. But it's basically the properties for the project. When you right-click on alpha and do properties, that's basically the file you're editing. So it's all right there in that file. Unfortunately, if you become a long-term C# developer, you'll be manually editing that file often, which is not fun. It's kind of hard to do and annoying, but you'll have to touch it sometimes. I just wanted to point out that's where the properties of the project are. It has things like the declaration that this is a console application. If it were some other kind of application or like a class library, that's where it's declared. So it has a bunch of declarative data about the project, a bunch of metadata, but no code. It doesn't have any code in it whatsoever. This program.cs is this file that we saw on the right, which is the one that we edited to say hello. And I can prove that by opening that in Notepad++. Like all code, it's just a text file. So just like we were looking at T-SQL and some of the JavaScript you've been working on, it's just a text file. There's no magic in those files. So I'm going to close that. Also want you to notice this bin and obj directory. Now, you don't have to follow along. I just want you to watch. I'm going to delete those directories. Those directories are part of the Microsoft style. That's what they do with the .NET framework. They have this concept, and so those are created for you. So you never create them, and if all goes well in your life, you'll never touch anything that's in them. Every now and then you might, but usually you don't have to touch them. So what I want you to do, or what you can just watch, I've deleted those files from the system, but I'm going to run my app. You don't need to run yours. I just want you to watch the left side of my screen. Those folders came back. They came back. The application runs. It's going to do the read key. I'll press a button and it closes. And those files remain. Now we're not going to talk about exactly what, we're not going to talk at all about OBJ. So ignore that one. I just want you to realize that they show up automatically. They're safe to delete at any time on your laptop. Not on a production server necessarily, but on your laptop it's totally safe. And I want to go in there and look at them. So let's, on your system, start following along again. Let's go into bin. You're going to see debug. By default, whenever you create an application with Visual Studio, it creates what's called a configuration of debug. I'll get into configuration files later. Sometimes this folder will have more subfolders in it. Right now it just has debug. Let's just go into that. Now I'm building, everything I'm going to show you in this course is going to be .NET Core 2.0. So .NET Framework, as I said, came out 18 years ago. It came out as version 1. There was a 1.1, there was a 2.0, there's a 3.0, there's a 3.5, there's a 4, there's a 4.1, 4.2, or now up to like 4.6.2 or 4.6.3. .NET Core came out a couple years ago. It started off version 1, there was a 1.1, and in other versions it's at 2, it's now at 2.1. These are just version numbers like we get all over software development. We're going to be doing .NET Core 2.0 in this course. It's like I said, it's very similar to .NET Framework, but it's basically being rewritten from scratch to be cross-platform. But all the really fun stuff, the really critical stuff is there. So if we go into that folder, we're going to see this. And all I really want to talk about for a moment, I don't want to talk about what all these files do. I want to talk about this DLL. And this is something that's wildly different from dynamically typed languages or dynamically compiled languages such as JavaScript. So let's think about JavaScript for a moment. You all have typed some JavaScript and probably loaded it in a browser somehow. I haven't watched all of the streams, but it's pretty straightforward that you type the JavaScript with your own fingertips, probably in an editor, maybe in Notepad, maybe in VS Code, whatever you've used. When you open up a web page, as you well know, and we can open up any page, you don't need to follow along. I'm just going to open up one myself. I'm going to open up Google. That's probably sufficient. Pardon me, my laptop's a little slower than I want it to be. This is a bad example. I'm going to go to a site that I know has lots going on and see if it has JavaScript on it. The point I'm trying to make, hopefully I'll be able to show an example in just a moment. These JavaScript files that are coming in, like this is CNN Analytics, this is some sort of share bar JavaScript. You can see all of the JavaScript on any website. So the way JavaScript works, the developer types that JavaScript, puts it on the web server, and the web server delivers that directly to the browser. It delivers it as is. The browser takes that JavaScript and just starts executing it, right? Now, I probably shouldn't do a news site. Please don't get distracted by the news. But if we look in the dev tools here, oh, I've already got one open. I got a JavaScript file. The point here is if I scroll down through here, we can read all of the JavaScript for CNN.com's homepage. So all the code that all those developers worked so hard to type was typed by their fingers, but is delivered completely as is to the browser, no security, and the browser actually runs that raw code. What this inevitably is, don't put comments in JavaScript that are unfriendly. 4-letter words are probably a bad idea. Anything that looks unprofessional in your JavaScript is actually sent to the browser. You probably wouldn't do that, but it's important to know that the intellectual property of JavaScript is always visible to the end users. You can obfuscate it a little bit and make it hard to read, but it is actually all there. C# is completely different, and that's why I want to do this comparison. We wrote C# a little bit on the right side in that program file, program.cs. Well, you'll notice when you pressed F5, it didn't open immediately. And if you were watching closely at the bottom here, we saw a lot of activity, right? You saw that there were some words flickering in the bottom left of Visual Studio. There was even an icon that looked like a box, had a little animation in it. It paused for a moment, and then it opened your project and you could see it. So everything in the .NET framework actually goes through 2 compilation steps. Okay? The first one is it takes the C# that you type with your fingertips and it compiles it to what we refer to as IL, Intermediate Language, sometimes referred to as MSIL, Microsoft Intermediate Language. Okay? This is a language that is not C#, it's not Visual Basic, it's not F#, it's none of those languages, but it's also not like what I would call computer code. Right? It's not the code actually sent to the CPU to be processed by the machine. It's an intermediate step. Okay? That intermediate step is saved in that DLL. It is actually possible to open it. Don't follow along. You don't need to.
Now go.
Yeah, now I'm going to try it.
Yeah, I think CNN like locked the browser up.
I'm not surprised.
Yeah, so much JavaScript. Y'all saw how many files were
Yes.
loaded in CNN. Amazon's kind of the same way. It's like thousands of JavaScript files,
Yeah.
and like with lots of other stuff running on the machine, it just sort of locks it up.
Yeah.
All right, they said they're good now.
All right, great. Sorry about that. That's my fault. I should have picked a less busy site. Okay, so to reiterate, this is our C# that we've typed, gets compiled to that intermediate language, and then right before the computer wants to actually execute that code, it compiles it on the fly. And I was mentioning that this is really complicated. Why did they do this? Well, you get multiple advantages as a developer. That first compiler is local in your machine, so that's that first attempt to make sure you've typed it correctly, that it's syntactically correct, that any namespaces you've referenced are present and visible to the system, that they're present in the correct directories. There's a lot of proactive validation that's occurring. I'm a little biased here. I do prefer these kinds of languages. I'm very biased. I've spent my entire career since .NET came out in the .NET framework, so I am biased towards it. I do love it. Very passionate about it. But I like the fact they get all that feedback up front. But what's really cool is you might ask yourself, well, why don't they immediately compile it to like the machine code? And that's because every machine's different. So the CPU in my laptop is an Intel Core i5, dual core laptop. But the Raspberry Pi has a totally different chip in it, right? Which means that computer code could not work on this laptop and the Pi. It's 2 different instruction sets. They have 2 different ways that you have to send instructions to them. So the cool thing about this second compilation is that it can be tailored to that particular CPU. What this means is that in theory, and I don't want to start any wars with anybody who might see this stream at any point, in general, these kinds of languages run faster. Generally speaking, there are exceptions, and people like to argue about those exceptions a lot, so I don't want to fray any emotions. But in general, the concept, if you think about it, makes sense. These languages would probably run faster if that jitter was written well and your C# was written well, because that machine code is running very efficiently for that particular processor. Things like JavaScript occur at a higher level, right? They're interpreted on the fly, which means that initial build step and the other one are kind of all happening at once, and it's not tailored to that particular CPU necessarily. It's running in basically an engine. So theoretically, those other languages run a little slower, but often those differences are negligible. Question?
Are you talking about Java or JavaScript?
JavaScript.
There's a big difference, right?
Yes, there's a huge difference. Yeah, the question is what I was talking about. I was talking specifically about JavaScript, which is what you're writing for the browser. Java is a completely different language. In fact, Java is a predecessor to C#, and C# was heavily based off of Java. Basically, the people at Microsoft, Anders specifically, took all the languages of the late 90s and cherry-picked all the features he thought were awesome. And Java has a lot of great features. It's got actually a larger market share even today than C#. They looked at Java, the original Java, the non-JavaScript Java. It's a totally different language. They also looked at C++ and they cherry-picked and created C# from that. But yeah, Java and JavaScript, I know their names are similar. They ain't similar at all. Java and C# are very similar. much more so than C# and JavaScript, which are fundamentally different because they are differently typed languages. So we got a little bit in some tech stuff there. I know you're not following along right now, but I wanted to go ahead and introduce you to the fact this is double compiled, because as we move along, we're going to be looking at these files in the operating system. And of course, as your career goes on, you're going to need to know that you typed C# in files on your desktop. But when you hit this build or run, this build solution, that build occurs automatically when you go to run it, so I'm not doing anything new in front of you. When you hit that build, these files on the left get created. Those are the things that are actually put on the production servers or distributed to clients. And their computers also require the .NET framework to be installed so that it can compile that to computer language. So it's a two-step process. I just want to point out that that happens and tell you where all the magic is. Okay? Any questions about all that I've said so far? All right, I have none here. Great. So I'm going to make Visual Studio bigger. So you've written some JavaScript and you've done methods. Let's go ahead and type a new method, and please do follow along. We're going to write a brand new method. So I keep on using the word method. So from JavaScript, you can think of it as function. They're always called functions. They have that keyword function. In these languages, such as C# and all object-oriented languages, which I'll describe what that means in a little bit, we use, we call them methods. A method can either return nothing or return one thing. In this case, we're going to do a simple one and return nothing. So just follow along. We're going to do static void I'm just going to call my method write the line. I'll do open paren, close paren, because we're going to accept no arguments. And Visual Studio, you're going to notice I'm able to type code fast. I'm going to go as slow as I can. But it has some cool features where if I do the open paren right here, it creates the close. And if I hit enter, it automatically formats it. You're going to see me doing that, a lot of things fast. If I ever do a trick that you think was neat and I didn't tell you how, just raise your hand. I don't want to skip over it, but I've been writing Visual Studio for so long that I might accidentally do something in front of you cool and not realize that I did it. That's just muscle memory. It's been 18 years of using the same software. But you can see we've created a new method. This is just like a function in JavaScript. What I'm going to do is I'm going to cut and paste that right line and put it right in there. And then I'm going to make that method call. So all I've done is move it to a new method. So I write the line, and we're going to call that method, and then read the key. Once you change your code to look like what I have, you can run it, and it will actually perform the same. You'll notice once again at the bottom, there's a little animated icon, right? It's turning my C# into that DLL right now. Then it actually runs that DLL in the debugging environment, which Visual Studio attaches to it. So you can see it still functions the same. So we haven't changed anything fundamental. I can press a key, and the application will end. So similar to functions in JavaScript, probably haven't impressed you too much. What I want to bring your attention to is this void. So in C# and all the .NET languages, like even Visual Basic.NET, at least most of them, the methods are designed to either return nothing or return something. I'm going to reemphasize that C# is a statically typed language, and it's very strict. So there's a lot of things you can be very flexible on in JavaScript that you are not permitted to be flexible on here. So we have to say void, and what we're saying is it doesn't return anything. It only does work, it doesn't answer a question. And that's true. All it did is write this line and end. That's not impressive. Let's do a new one. We'll do static, we'll make it a string. So what we're saying here, and I'll go over what static means later. Just keep typing static whenever I type it. We'll talk about what that means later. What we're saying here is we're saying string. We're guaranteeing that it returns a string. Okay? I'm going to call this get message. Still not going to put any parameters on it. Now the first thing you'll notice is when our method is empty, it's also a function. If you want to call it a function, I'm going to call it a method. It's already got red squiggles. So if you put your mouse over that, you'll learn why. Blah, blah, blah. Not all code paths return a value. Now you don't get this in other in other languages, especially like a JavaScript. It's already unhappy because we said we promised to return a string, and we're not returning one. It already won't work. In fact, you can experiment with that. If you go up here to build and build solution, this means try to turn my C# into that DLL again. It'll say build failed at the bottom left, and it will probably pop up an error list, and it will give you that same message that says no, I refuse. It absolutely refuses. And just to emphasize that, you don't have to follow this part. I'm just emphasizing a point here. So I'll hit build with a build error. So I still haven't fixed the error. It'll create those directories. But that folder's empty. So it won't even build that intermediate file. The DLL does not get built. It could never go to production. You cannot deploy it. It's very unhappy. So let's make it happy. Let's return something. We return with the return keyword. You've probably seen that before. It's the same thing here. I'm going to do a different message just for fun. Hello VCU. How about that? All right. Strings in C# are always double quotes. You can see in the development environment colors them very well. Lots of great color coding. And what I'm going to do is I'm going to go to this original method. I'm going to change that original hello and power, and I'm going to call get message right from inside of it. And I'll leave that on screen for a moment. So once again, we're going to start the program. We're going to call the write the line method. It's a void, so it's just going to do work. That method's going to try to write something to the console, and the message it's going to write is going to call out to that local method, which we return that string. And if I press F5, we should see hello VCU. Yay! Works perfectly. But now, and I want you to follow along, we're going to break it, but then we're going to fix it when we're done. I'm actually going to use the clipboard. So you remember I showed you at the beginning of this morning, I showed you that JavaScript where I had the Alpha, Bravo, and Charlie, and I did the 2 and the zebra. I was able to use the plus sign and push a number and a string together. Well, this method returns a string. Let's say I tried to return a number. I'll try to return the number 99. Same problem. That 99 has red squigglies on it. If you put your mouse over it, cannot implicitly convert type int to string. Sorry, I moved my mouse there. There we go. So you'll notice, although JavaScript was very powerful and flexible, it turned our 2 into a string version of 2. None of that type conversion occurs automatically in C#. And if you become a long-term C# developer, this will be your truth forever. It's a fundamental truth of the language that it's extremely strict about types. If you want to convert them, you can. I'll show that in a moment because we have a question.
What happens if you put 99 in quotes?
Excellent. The question is, what if I put 99 in quotes? Well, now it's a string. It's perfectly fine. And I'll go ahead and run it just to show you. You don't need to follow along, but just to answer the question, this actually works fine. 99. So we see that
99 is not a number right now.
that's correct. It's a string that contains characters which happen to be numbers in our numbering system. That's a good question, though. So I'm going to put it back to 99, the number. So number's not a string. Strings and numbers, totally different things. And it gives me the squigglies. So one of the things we're going to talk about, and I'll show many examples here in a moment. With this type strictness, obviously the language is full of conversion mechanisms. It has many, many. So just because you have a number doesn't mean it could never be a string. The thing I want to point out to you is the language itself won't ever automatically work on that for you. You have to declare in the code that you want something to be converted. Well, there's already one for conversion. If you hit the dot, no, that might not work. So I put it in parentheses. That's just to give me the IntelliSense. The parentheses are not profound. They're just a way to make the IntelliSense pop up for numbers. It can't tell the difference between me trying to type 99.5 versus 99, please let me have access to the methods on it. So we hit the dot, we see everything that can be done with that particular type. One of the things you can do, every object, which means basically every variable in C# has a toString method on it. You can call it. Now what it does varies from type to type. But for this, it converts it to a string. I'm going to run that. We see 99. Prints correctly. Alright, now let's create a variable that has the value 99 in it. So I'm going to call var value equals 99. And I'm going to do value, actually I'll pause for a moment and point out something else cool the editor does. You'll notice when I did var value equals 99, it gave me green squigglies. The variable value is assigned, but its value is never used. Another nice feature of the development environment, it's telling us that we've declared something that we're not using. That's usually an indicator of a bug. So it's kind of nice that it's trying to tell us that. It's just a good feature. But what I really want to do is that. So I'm declaring the value of 99, I put it in that variable, and then I can do variable.toString. This will work. Just to show you, to re-emphasize, if I take off the toString, I cannot return that value. That value is an integer. You can confirm a type by putting your mouse over it, and you get cool pop-ups that say int values. That's an integer. Int is not a string, so it won't do anything automatically. I'm going to do it with toString. I'll run it, we'll get the same result. $99. Works perfectly. But I want to talk about this line that I just added, line 20. So var value equals 99. That looks and functions pretty much like you would expect. You know, in JavaScript, that's kind of what you do. You do var x equals something, and that works. Same thing here in C#. But I do want to emphasize a point. You can do comments in C# with double front slashes, which I'm doing here just so I won't have a build error. But I want you to look at those two lines. Var value equals 99, int value equals 99. They are identical. Okay? So the one that says int is just where we're explicitly stating I want this to be an integer of 99. But the way the language works, it's still a static type, but it can do it can infer its correct type. Because 99 is an integer, it goes, he must have meant integer, and so that's what var does. Okay, so value is an integer in both cases. So just look at those two lines and just accept what I tell you, that they are identical. And I'm emphasizing this because there are a lot of developers in the C# world who think that they are not. Even developers who have been doing this for years think that one of them performs better and does something fundamentally different. They believe that the var is some sort of loose type, and they are incorrect, and I have to prove it to them usually. So these two lines are identical. I've commented one so it won't break. I'll uncomment it so you can see it, but you're going to see red squiggles. That's fine. But those two lines are functionally identical. Okay? You're going to see me type var a lot, but in every case where I type var, you have to realize that there is an actual value. Var is not a type. It's just a keyword in the language. The actual type of value in both cases here is an integer. And I want you to remember that. You'll notice I'm harping on this quite a bit. Everything about static type languages, especially if you're used to another language and you were introduced to programming in this course with a dynamically typed language, these things are very type strict. There's not a lot of flexibility. Is that a question?
Yeah, will var recognize any data type? So obviously recognize ints and strings, will recognize booleans and
Yes.
Okay.
So the question was, would var recognize any data type? And the answer is yes, 100% of them. Yeah, without fail. Without fail. Cool. You'll notice we did get red squigglies. Once again, the variable value is assigned, blah, 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 blah. It's very unhappy that I've duplicated this. And it considers that one unused. So we'll put it back the way it was in a way that actually works well. So the actual type here, there are a few synonyms in the C# world, and I'm just going to type two things on the screen here. You don't need to follow along right now. I just want to point this out. These two, for example, are synonyms. So because we came from a C++ world, from a Java world, C# always has these all lowercase types in them, and they're usually colored blue, and that's what people usually use. But if you ever see something that looks like int32 or these two are both identical types, I'm just typing them. You don't need to follow because it won't build for you. I just want you to know that there are a lot of synonyms there. So you'll see me use them interchangeably in front of you, but that's just because they're synonyms. So let's go the other direction. Let me do parsing. If you want to save your file, you can, or you can save the text. I'm going to delete all this. I'm going to clear it off because it's going to be a lot of noise on the screen now. I'm going to show you something new. So I already showed you what happens when you go from integer to string. I can always do something like this, right? So I declared a value of 99, which is an integer, and I'm then able to convert it to a string by assigning it to the result of value.toString. So you can type that if you want. That's fun. You can also go the other direction. The question, of course, is how would you go the other direction? How would you go from a string in there? Well, they really helped us out. They really helped us out. Another reason we pull in this using system namespace is it comes with a lot of feature sets that are very common and pretty much pervade all applications that are written in C# or Visual Basic or F#. You can always do the type dot, okay, and you get some IntelliSense, and you can do some pretty cool things. The number one thing is you can parse. And you've probably heard that term already. Parsing is the act of turning a string into something else, or tearing it into multiple strings, or doing something like that. We can easily do that. So I'm going to do other value equals int.parse. I'm going to do the string version of 99. Oops, make sure I type it correctly. Without the typo. There we go. This is how you go the other direction. So if for some reason you had a string version of 99, which was asked about earlier, and you wanted to convert it to an int via parsing it, this works. Okay. There's also a try-parse. Try-parse is very similar. I'm not going to actually use it actively. I'm just pointing out that it's there. I'll show you that a little bit later this morning. We can parse and pull out those values, and we can basically ask it to try to parse, and if it doesn't work, please don't crash, just give us a Boolean. It's basically the try-parse version. I'll show try-parse a little bit more in just a few minutes. Okay, we can go this other direction. All right. Okay, let's look at something kind of a feature over here of the project itself. So if you go to the project, remember we're doing a console application. All of those applications, even Git, it has command line parameters. We're going to make our program act like it got delivered some parameters. So we're going to be running this in the development environment. We want to fake that somebody gave it parameters. We're going to do that by right-clicking on Alpha, go into Properties. There'll be a tab on the left that says Debug. Sure. Yeah, I'll start over, no problem. That's okay, my laptop's not the fastest. I deleted the code because we're going to be doing something different. I just wanted to show parsing is possible. So once again, I went to the project itself, I highlighted Alpha, not the solution, but the project. The project always has that icon, and not this little purplish one. Right-click in Properties. Yep. You're going to see me right-click in Properties often, so just be ready for right-clicking on your project and clicking Properties. And then on the left, there's going to be some tabs. We're going to go to Debug. This tab is for when you want to, as it suggests, it helps you debug your application. In this particular case, see where there's a box here that says Application Arguments. Let's put in the numbers, we're going to do 1 space 2. This will be just like we called our application from the command line and passed in 2 parameters, the number 1 and the number 2. Then we're going to save that and close it. So get that typed in. Now in the actual program, in that main method, it already comes stubbed out with a string array. Right? That's just like, I believe it's just like in JavaScript. We have open and close square brackets. That's definitely an array. That says that it's not a string, a single string, it's an array of string. Okay, and it's called args, command line arguments. That sounds pretty good. And we know that it has 2 values in it because we just typed in the number 1 and number 2 over there. So let's say the purpose of the application is to take in 2 parameters, 2 command line arguments, which we've already put in that debug window, and it's just to add them together and spit out the result on the screen. So what's 1 plus 2? Glad somebody answered. That shouldn't be too hard on you. So the first thing we might be tempted to do is do var result equals args, and it's an array. It's 0 based. So yes, C#, 0 based. Just remember that all the arrays are 0 based. I believe they are in JavaScript as well. Yeah, so that's no different. You might be tempted to do this. You can go ahead and follow along if you want. And we'll do console.writeLine, and we'll just write that result. Gotcha. So what have we done here? We declared a new variable result, and we assigned it with the equals operator to args, the first argument plus the second one. And we did use this plus operator right here. If we put the mouse over result, we see that its type is string, so we can write it out to the console. Let's run this and see what happens. And if you want, take a guess before it happens. Oh, 1 plus 2 is not 12. What actually happened here was it concatenated 2 strings. Remember, no conversion is going to happen on your behalf in C#. So we passed in a string of 1 and a string of 2, and the plus operator is how you concatenate strings in C#, right? So it put the 1 next to the 2 and gave us a single string value of 1, 2, which looks like 12. It's clearly wrong. So what did I forget? Type conversion, change to integer. Both of you are correct. 2 ways to get the answer correct. What I really want to do is int.parse on both of these. So you can follow along. You can type it in just like I did. Bam, int.parse. Now that plus operator is going to perform math. Because we turned that first argument, which is the string containing a 1, into an integer of 1, we take the second argument, which is string of 2, and convert it to an actual integer. This plus becomes 1 plus 2. And the result, if you put your mouse over it, let me save. Its type is now int. It used to be string. Now if we run this, three. Now you might be thinking, if you're a step ahead, you might be thinking, well, wait a second, 3 is an integer, but it wrote a string. How is that possible? Well, they have, there's a feature in C#, which we will talk about more later on in the course, called overloading. You'll notice, so what I did here, just so you see, this is a trick I use. I'll remove the open paren and retype it, and it gives me this cool pop-up. Well, you'll see that it's got little arrows on it. If you flip through them, what you'll see is that there are actually 18 console.writeLine methods in existence, and all of them take different parameters. And it just so happens that one of those, that we call them overloads, is an integer. So you might have expected me to have to convert this to string. And that would work. I'll press F5 just to show you that it worked. But if you were wondering, well, wait a second, Derek, you told us that the types are all specific. The reality of it is there was a WriteLine that takes in an integer. Microsoft was just nice enough to provide a whole bunch of them. There's basically an overload per primitive type, which an integer is a primitive type. So it just happened to work. It happened to work because they had that method in there. But both of these get the same job done. We were successful. Now we're actually adding 2 numbers together. And we can prove that. If you go back to alpha, go to the properties. Remember I told you we'd go into this often. Change up the numbers, and you can make them anything you want. I'll do 3 and 4. If my program is written correctly, I should see a 7. I see a 7. Perfect.
How did we get to the debug again?
The debug is right-clicking on the project, which it'll say Alpha in the Solution Explorer.
Got it.
Properties. And it's the debug tab.
Debug tab.
Yep. remember, all we're mimicking here with this application arguments is command line arguments, as if we were running it from a command line, like I was showing you earlier. But obviously we're not. We're hitting play in the development environment, or hitting F5. So we have to have somewhere to place those arguments so it acts real. And this is the place you do that. Okay? So we have other types. Let me look at my notes here real quick. I want to show some other. Yeah, I'll show a few other types just to show that they're out there. There are a lot of what I call primitive types. It's a pretty common term for it. Date time is one of them. So you can type date, it'll automatically give you this pop-up. You can at any time hit tab or dot. It will go ahead and type out the one you have selected, because you can up and down arrow in here. You can see there's quite a bit we can do with dates. The date manipulation in .NET is very powerful. Got a lot of features to it. So I'll just show you some of them just to sort of give you an idea. We'll do UTC now. So now we have a variable. I'm going to get rid of this this code at the top. We've already proved ourselves that we know how to add. So that's good enough. So I've created. That actually takes the current time, but in UTC time. That's Greenwich Mean Time. The time approximately in London. As we've talked about already in this course, I'm of the opinion, and I'm always careful when I give opinions, that we always store UTC time in software. That's my personal preference, and then we convert it to something more user-friendly on some UI. So you'll see me always do UTC now. There is a local now, but you have to be careful of that one, because depending on which server it's running, you might get a different date. So that can be really scary. Creates some weird bugs where when you sort things by date later, they're out of order by an hour or 2 or 3 or 5. So let's do UTC now. And for fun, let's go ahead and write it. So we'll do console.write line. You've seen this many times. There's probably an overload for date, so it's going to work first try. We'll run that, and we should see the time approximately 5 hours off from where we are. 1:45 p.m. That's UTC time. So that's working. That's cool. We can do some interesting manipulation. So let's do a new date. We can do created dot. And there's all kinds of methods here. And properties. These are all the things we can do. So let's add a month to it. So you can call dot add months. Just pass it in a 1. And now I'm going to console write line the new date. So we should see July 21st, 1:46 p.m. July 21st, 1:46 p.m., 33 seconds. And just, we won't go through all these methods. I'm just going to scan them visually, and obviously you can add many things. You can pull out different portions of it. So you can pull out just the date without a time, which basically puts the time at midnight. You can pull out just the day aspect, which is an integer. So today that would be 21. The day of week, you can actually get day of week. What's the type? So day of week. You don't have to follow this part. I want to run through a few of these methods, just sort of show you what's available. So day of week should probably be Thursday, or something close to Thursday. Thursday. So that's already done for you. I just want to point out that that a lot of these types have a lot of stuff built into them, so that you don't believe when you're given a task later that you really need to like write an equation or write a switch statement. It's all done. All that common date stuff is very powerful. It's already done here. You can pull out the hour part, the millisecond. Kind just tells you if it's UTC or not. Ticks, that's operating. That's ticks since, I actually don't remember when the beginning was. I think it's from year 0 or year 1, January 1st, year 1, I think. The time of day only, so that's the time of day without a date stamp. And you can convert it to lots of other kinds of strings. So I'll do, just for fun, long date string. You know how people like to format dates and times differently depending on their opinion. So the long date string is different from a short date string. And there are a lot of custom strings you can do. So this one's Thursday, June 21st, comma, 2018. Right, but we could also do some other one. To long time string. $13.48.50, so it's only the time in 24-hour time. So I'm pointing this all out to you because all these existed since the beginning, but I see a lot of developers who think that they need to write a lot of code. And I want to emphasize that the .NET framework comes with a huge amount of libraries. We're looking at just in the system namespace, just on these primitive types. There's a lot of type conversion, there's a lot of manipulation you can do, there's a lot of built-in math and algorithm stuff on many of these types. You don't need to reinvent any of those wheels. The first place you want to check, and you can see I'm actually doing it here in front of you. If you're ever not sure, create a quick console on your development laptop, just like we did today. Make a variable of that type its name, hit dot, and look for it. Use this IntelliSense. I'm heavily dependent on this IntelliSense. Don't think that just because I've been doing this a long time, I've memorized everything. No, that's a waste of my effort. What I know instead is to hit dot all the time and look for what I'm looking for. And there's probably something on them that's going to be helpful. A lot of these types have all kinds of methods on them, especially date. Date manipulation in .NET's very powerful. So don't reinvent any wheels there. Any questions so far? All right. Let's talk about debugging, because I can't really give you an exercise until we talk about debugging, because inevitably you're going to need some debugging skills. Right? You're going to need to know how to fix a boo-boo. There we go. I got a lot of white space. Let me get that all off the screen. So here's something really cool. I assume we've used breakpoints in JavaScript. Have we used? Okay. So we have breakpoints here as well. They are similarly powerful. All you got to do is put your cursor on any line of your choosing, and the hotkey is F9. You'll know if you did it right because it's got this big bold coloring that we do here. So what this does is put a breakpoint on, so when we hit run, it will break on that line. And I want to emphasize it breaks before the line. It doesn't execute that line. You're breaking right before that line executes. We press F5. The debugging tools in Visual Studio are extremely powerful. They've been maturing for we're getting close to 2 decades now. They're very powerful. Many versions of Visual Studio have come out. They're very powerful. You can see what happened. So it ran our application. I'm going to point out that we have not written to the console yet, right? So we haven't actually done that write line. That line is not executed. This is our app, but it's been frozen in time. So the debugger has broken in, frozen time, and yellow is where we are. And you can tell if you put your mouse over created, it actually has that correct date. You even have this little expanding thing. You can see all sorts of information about that date. Okay? You don't have to use the mouse over. There's also a window. You might need to open it up. Let me remind myself which one it's in. There's an output there. Command. Locals. Yeah. So if you go to the debug menu, that has multiple windows open. I have one open. You're going to want to open the locals window. Locals is kind of nice. I'm going to pin it for just a moment. Locals basically takes all of the variables that are in scope right now and puts them in this little designer, so you don't have to put your mouse over. You can see our created variable is there. There is the date. We can expand and we see that same list we saw when we moused over. We can learn all sorts of things about all the variables in play right now. And we can execute one line at a time, similar to what you were able to do in JavaScript. I'll do another breakpoint on the very next line. I can just hit play. It will advance to the next line. Now, if you look at our application, it's actually already rendered that line. It has not yet gone into pause mode. Not that it matters here. Now it's paused. Hit a button and it ends. So I just wanted to point that out. Use the F9 key to put breakpoints, and that pauses your program right there, and you can see its scope. Now, this is not a complicated program, right? It's got one date stamp in it. Not really that extremely powerful, but you will inevitably work on methods that have many variables in play, many parameters. There's a lot of global variables, and you're only going to be able to debug it with these breakpoints. Very powerful stuff. There's other information you can get from breakpoints that are way out of scope for the course, but I assure you can get things like what methods were called before here, what's the call stack, all the way back to the beginning of the request, if it's a web application, or to the main, if it's a console application. You can get all sorts of stats about RAM, what's in memory, what's the status of the machine. Very powerful stuff, but we won't go into all of that. I just want you to know to use that F9. We'll eventually have an exercise soon enough, and you're going to want to tinker with that stuff. Debug, reading from console. I've already showed comments. That's good. Let's try. Let's just try one quick exercise. I actually accidentally did one in front of you, so I can't give you the one that I put in my notes. I'll create one here on the fly. Here we go. What I want you to do, and you can use this application or you can create a new one, and now's the time to take notes. I'm going to make this up on the fly, and I will retype it in Slack. I want to give, we'll do a same pattern here. We're going to pretend the application takes 2 arguments, kind of like we did here, the 3 and the 4. But instead, I want you to have it pass in 2 dates with timestamps, and I want the application to print out the difference between the 2. Right? So if we were to put in as example, and you can use this demo data if you want, that I'll say out loud. If we were to put in tomorrow morning 8 a.m., so June 22nd 8 a.m. as the first parameter, and then put in tomorrow morning 9 a.m. as the second parameter, I would want to see a difference of 1 hour. And you can print that anyway, as long as you arrive at 1 hour, that's perfectly fine with me. I would not mind if you, instead of saying 1 space hour, it'd be perfectly fine if it said 1:00:00 hours, minutes, seconds of difference. That's fine too. As long as it's really doing the subtraction correctly, that'd be fine with me. So it's basically a technique we've done now, but it's kind of, you'll have to build that with your own fingers. This should be a pretty short exercise, and then we can get back to learning new stuff. Any questions about the specification of the exercise? I will type it in Slack in just a moment. All right, let's do it. The difference between 2 date times. Harper, do you want me to stop the stream for the exercise?
Yeah.